In the paper, a variational principle in the parametric geometry of numbers by Das, Fishman, Simons, and Urbanski, they also developed the so-called Hausdorff and packing game and used it to prove their variational principles, which give an application to computation of the Hausdorff dimension of a set of singular matrices. The game is defined as follows. Given a parameter beta between 0 and 1, and a delta that is positive, there are two players, Alice and Bob. And Alice begins by choosing a starting radius rho naught greater than 0. And in the zeroth turn, Alice chooses a non-empty, finite 3 rho naught separated subset A naught in the space Rd, where D is just an integer. And by 3 rho naught separated, we mean any two elements in A naught has distance at least 3 rho naught. Bob will respond by choosing a ball B naught that is centered at some x naught with radius rho naught. And x naught is chosen from A naught. Okay, now let's draw a picture. Here are the points in A naught. And there are 3 rho naughts separated, which means the distance between them are at least 3 rho naughts. And we can think of them as 3 balls of radius rho naught for Bob to choose from. So Bob will choose one from them. That is the 0th turn. Now let's look at the first turn. In the first turn, Alice will choose a non-empty, finite 3 rho 1 separate subset A1 that is contained in Rd. And here rho 1 will be equal to the beta times rho naught. And we have one more requirement, saying that A1 must be contained in the ball centered at x naught, which was Bob's choice, 0th turn, and the radius now is 1 minus beta times rho naught. Remember here, x naught was Bob's choice in the 0th turn. Now let's draw a picture. The outer circle has a center x naught and a radius rho naught. And this inner circle has radius 1 minus beta times rho naught. And those points are Alice's choices in A1. And there are 3 rho 1 separated, which is 3 times beta times rho naught. And Bob will respond to this by choosing a ball B1, which is centered at x1 with radius rho 1. And here x1 is in A1, Alice's choices. And in general, in the kth round, Alice will choose a non-empty finite 3 rho k separated set A sub k in Rd, where here rho sub k is beta raised to the power k times rho naught. And we need ak to be contained in the ball centered at xk minus 1 with radius 1 minus beta times rho sub k minus 1. And in the picture, we'll have the center of this ball equal to xk minus 1, which was Bob's choice in the k minus 1's round. And rho sub k minus 1 is equal to beta raised to the power k minus 1 times rho naught. And the point a sub k is again denoted by the crosses in the inner circle, which has radius 1 minus beta times rho sub k minus 1. And they are supposed to be 3 rho k separated. Which is 3 times beta raised to the power k times rho naught. And Bob will respond to this by choosing a ball in the kth round, denoted b sub k, which is centered at x sub k with radius rho k, where s sub k is in ak, the Alice choice, and the radius rho k, which is beta raised to the power k times rho naught. And the game will move on. Note that the condition guarantees that B0 contains B1, which contains B2, ... So each one of them will be contained in the one before. And because the radius rho sub k is shrinking geometrically, if you consider the intersection of all those balls from k equals 0 to k equals to infinity, then we have the limit point in the intersection of those closed balls, which is denoted x sub infinity. And this x sub infinity will be called the outcome of the game. And the game itself will be called delta dimensional Hausdorff, or respectively the packing game. Another question is, who is the winner of the game, and how to determine the winner of the game? What is the criteria? So now we let script A to be the collection of a sub k's, where k is a positive integer. Remember, a sub k's are the choices of Alice, and we compute the following number. Lower delta of script A will be defined to be the lim inf as k goes infinity of 1 over k times the summation I from 0 to k of the ratio log of the number of points in AI. Remember, a sub i's are finite sets over the negative log of b. So those a sub i's are the choices for the Alice in the kth round. Now respectively, we have the upper delta of script A, which is defined to be the lim sup as k goes to infinity of 1 over k times the summation as I goes from 0 to k of the same ratio. And the first one corresponds to the Hausdorff game. While the second one corresponds to the packing game. And those two numbers, lower delta of A and upper delta of A, represents the Alice score. Another question is, how do we determine when Alice is winning? Here's the definition. A set S contained in Rd is said to be delta dimensionally Hausdorff, respectively packing, beta winning if Alice has a strategy that simultaneously ensures first, x infinity, the outcome, is in S, and second, this outcome, remember this outcome is the intersection of all balls of choices of Bob. And secondly, is lower delta of script A, and respectively the upper delta of script A is at least delta. And the set S is said to be delta dimensionally Hausdorff and respectively packing, winning without beta if it is delta dimensionally Hausdorff or respectively packing, winning for all sufficiently small beta.